Our lab for tonight sort of had a dual purpose. Number one, we were trying to figure out the percentage of magnesium and oxygen in a magnesium oxygen compound. So to find the percent magnesium and percent oxygen in a magnesium oxygen compound. And then really in number two, what I wanted you to do was take those percentages, let's just call them percentages, and find the atom to atom ratio. In other words, mgx OY. I want you to solve for the x and the y using those percentages. Let's assume, just for the sake of argument, that just for the sake of being consistent, I guess, that we had the mass of the paper as 1.11 grams, and then you had the paper with a unit, grams. Paper plus magnesium in grams was, I think, something like 1.41 grams. And then the mass of the magnesium oxygen compound, so let's call it MgXOY, and paper in grams was like let's call it 1.61 grams. Just to be on the safe side here. And so let me clear that real quick. And then it says, write out the theoretical formula for the reaction of magnesium with oxygen to form the magnesium compound MgXOY. So this would be Mg, and that Mg was a solid, plus oxygen, which we know from our Brinkelhoff is a diatomic molecule, and we would have MgXOY. Okay, so far so good. And this substance was, and you saw it fall, a solid. So the starting mass of magnesium, well, we had the mass of the paper, which was 1.11 grams, and we had the mass of the paper and the magnesium, which we said was about 1.41, so 0.30 grams, and then we had 1.61 minus 1.11 is going to be 0.50 grams. Okay, so we should have about that. And so write a for every statement comparing the amount of magnesium in the magnesium oxygen compound. So if we were to do that, we would say for every 0.3 grams of magnesium, there are 0.50 grams of MgXOY. And a percentage assumes that the total compound is 100 grams. So write a new for every statement substituting a value of 100 for the magnesium compound. So that means I'm going to put 100 there, and that's for MgXOY. And I'm going to say for every blank grams of Mg, there are 100 grams of MgXOY. And if I compare these two values, 0.5 to 100, well, 5 times 20 would be 100, so 0.5 times 200 would be 100. So 0.3 times 200 would be 60. Okay, and so it says solve for the amount of magnesium, which we just did. This value represents the mass percent of magnesium in the magnesium oxygen compound. So what this is saying is that this compound is 60%, and this is the important part. We can't just leave it as a percent. This is 60% Mg, and specifically that's by mass, because I was comparing grams to grams. I wasn't comparing milliliters to milliliters. I wasn't comparing moles to moles. I wasn't comparing atoms to molecules. I was comparing grams to grams. Okay, so 60% magnesium. And then it says, what is the mass of the oxygen that was used in the reaction? Okay, so we should know that if I had 0.51 grams, and that was the MgXOY, right? And I subtract that from, I'm sorry, 0.50. And if I subtract that from 0.30 grams, which was the mass of the Mg, that gives me just the mass of oxygen. So it says now write it for every statement comparing the amount of oxygen in there. So again, just like we did last time, for every 0.20 grams O, there are 0.50 grams MgXOY. Okay, and again, a percentage assumes that we are comparing it to 100 grams of the total compound. So this is going to be 100 grams MgXOY. And this value over here is our unknown, grams of O. So for every blank grams of O. And again, I'm multiplying by 200 to get to 100. And then 0.2 times 200 would be 40 grams. And so again, number 11 says solve for the amount. Well, this is 40% oxygen by mass. Okay. And so we're just kind of trying to walk you through how to do this. So what are the percent of oxygen and the percent magnesium? Well, the percent oxygen was 40%. And then the percent of magnesium was 60% by mass. And that adds up to 100%. And what's the reason why? Well, this is the two substances that are inside of this compound. Okay, what's the molar mass of magnesium and oxygen? And write that as for every statements involving grams, atoms, and moles. Well, we could say that for every 1 mole of magnesium, there are, and from our periodic table, 24.31 grams. And remember, that corresponds to 6 times 10 to the 23rd atoms. And then again, for every 1 mole oxygen, there are 16 grams and 6 times 10 to the 23rd atoms. And what I'm trying to point out here is that when we have 1 mole, we have 6 times 10 to the 23rd. 1 mole, 6 times 10 to the 23rd. So when we're really comparing a mole to mole ratio, we're really comparing how much heavier magnesium is in comparison to oxygen. So oxygen is a lighter substance than magnesium. Okay, and then it says write for every statements for the following possible magnesium-oxygen compounds and include the terms grams, molecules, and moles. Just like what we did before, except this time for every 1 mole of Mg1O1, again, there are 6 times 10 to the 23rd molecules, because this time I've got that substance there is a molecule, right? And the molar mass is going to be the addition of both of those, which will be 40.31 grams. Okay? In this one, I've got twice as many oxygens. So again, everything's going to be the same, except this will be MgO2. And this time, instead of being 40.31, this is going to be 56.31 grams. Okay? Everything else will be the same. So you guys can finish up the rest of that. Number 15, find the percent magnesium for each of the following magnesium and oxygen formulas using molar mass. And again, this time, it says right there that you're going to need 2 for every statement. So I'm going to make a little smaller pen here. So I'm going to say, from my problem up there, I'm going to say for every 1 mole of MgO, there are 6 times 10 to the 23rd molecules and 40.31 grams. Oops. No, we don't want to do that. Sorry. I would go back and rewind this, but I'm not going to. For every 24.31 grams of magnesium, there are 40.31 grams of MgO. All right, and we're comparing this based on 100. So I'm going to have 100 here. Blank grams mg. There are. And again, 40.31 is about 2.5. So I'm going to multiply this by 2.5. And 48 plus 12 is 60 grams. So we're saying that based on MgO, this is 60% Mg. And of course, then it's 40% O, which matches what I found experimentally. So you're going to finish up the rest of those and figure out the percentages and compare those. But I'm going to skip ahead to question number 16, which says, based on these percentages, what do you think the compound was? Well, based on what I found, based on my results, MgXOY should be Mg1O1, which is, if I wrote this as an equation, that would mean if I go back to number 1, if I go back to question number 1, I know that I had most of that written. Mg plus O2 goes to MgO. In other words, those ones are kind of unnecessary though. And if I draw a particle picture for this, and I balance the shapes, so if I say a triangle is Mg and a square is, oh, let's make a circle O. And I say a circle is O, then I have triangle plus O, right? Gives me triangle O bonded together. And you'll notice that on this side, I've got 2 circles, and on this side, I only have 1 circle. So that's going to be a problem. So I'm going to add, I'm going to add another triangle O. And if I do that, then I need another triangle over here. So again, same boxes, same volumes. And so as a result, then I have really, if I balance this correctly, I've got 2 triangles here, 2 triangles here, 2 circles, 2 circles. So I need a 2 out in front of here and a 2 out in front of here to show that I needed twice as many triangles as I started with. Oh, ignore those circles because I guess now you can make it a circle. Oh, don't worry about that part. Okay, so I got 2 triangles over here to match my 2 triangles over here, and I've got 2 O's over here with 2 O's over here. That's where this 2, 1, 2 relationship comes from. Okay, I hope that helped. I'll see you guys tomorrow.